Right. So we were discussing if two vectors are equal. Now the example is if the vector on the left hand side is equal to the vector on the right hand side. In our physics problems, this is true because of Newton's second law. So Newton's second law is actually a vector equation. So the force is a vector is equal to mass into acceleration, which is also a vector. Now what we do is we break up F into fxi plus fyj. We also break up A into axi plus ayj, and these two vectors are equal. Just to repeat, max is a scalar, may is a scalar, fx is a scalar, fy is a scalar. The whole thing here is a vector, and this whole thing here is a vector which is equal to f, and this is equal to max. Now what this means is, as per our previous discussion, what this means is that fx is equal to max, that is the x components have to be equal, and fy is equal to may. These are two scalar equations. This is actually a, so I'll repeat this all over again. Newton's second law is a vector equation. Now in two dimensions, one vector equation like this is actually equal to two scalar equations. And the reason there are two scalar equations is because the x component has to match with the x component and the y component has to match with the y component if the two vectors are equal. Similarly, in 3D, we will have one vector equation like this equivalent to three scalar equations. There will be a third equation which says fz is equal to maz, but like I said, our focus is on two-dimensional problems, so we'll be using this. And now finally we are ready to solve two-dimensional Newton's laws problems. I hope I haven't lost you, because this is going to be much more interesting. So let's start with two-dimensional Newton's laws problems in the next class, and with that you'll also be able to finish the assignment. Do have a go at the assignment. All the best.